Thanks for watching my video today. Let's evaluate the Dirichlet series of zeta function. Okay. So in the previous video, I have evaluated for the Dirichlet series of zeta function, and this is another one again. Okay. From the last one, it is the real part of s is greater than 0, I think, right? For this, zeta of s is equal to 1 upon s minus 1, sum from unequal to 1 to infinity, and n plus 1 by 2. This is something like what sum of natural number up to n times, right? So which is into 2n plus 3 plus s upon n plus 1 to the s plus 2. S is this, okay? Minus 2n minus 1 minus s upon n to the s plus 2. This will be converged when the real part of s is greater than -1, okay? Actually, our Riemann zeta function is Riemann extend the zeta function up to complex plane, okay? That's why we call it the real part must be greater than -1. So imaginary part we can take any number. Now let's prove this one. So from the right hand side, okay? From this right hand side, let's try to prove this. So this is the simplest proof I came up with this. So right hand side equal to 1 over s minus 1, sum from n equal to 1 to infinity and n plus 1 by 2, 2n plus 3 plus s upon n plus 1 to the s plus 2 minus 2n minus 1 minus s upon n plus n to the s plus 2. Now just plugging the value of n, okay? N equal to 1, 2, 3 and so on. So 1 over s minus 1, when you plug here 1 into 1 plus 1 is 2 upon 2, and this is 1, right? N is 1, so 2 plus 3 plus s upon n is 1, so n plus 1 plus 1, 2 to the s plus 2 minus, and this is n is 1, so 2, 1 is 2, so 2 minus 1 minus s upon n is 1, so 1 to the s plus 2 plus. Now for 2, when n is equal to 2, this is 2, 2 plus 1 is 3 upon 2, and this is n is 2, right? 2 to the 4 plus 3 plus s upon 2 plus 1 is 3 to the s plus 2 minus 2 to the 4 minus 1 minus s upon, this is 2 to the s plus 2 plus. Now when we plug n equal to 3, 3 into 3 plus 1 is 4, 3 into 4 by 2, and this is n is 3, right? 2 3 are 6 plus 3 plus s upon, and n is 3, 3 plus 1 is 4, 4 to the s plus 2 minus 2 3 are 6 minus 1 minus 6 upon 3 to the s plus 2 plus. And if you plug 4 and 5 and so on, right, it will keep going on. So which is, let me put up to third term, okay? Now which is 1 to the s minus 1, right? This one 2 can get cancelled out, right? Only 1 is left, so 1 into something is these things, right? So this is 2 and 3 is 5, 5 plus s upon 2 to the s plus 2 minus 2 minus 1 is what? 1, right? 1 minus s upon 1 to the s plus 2 plus, here 2 can get cancelled out, 3 into here 4 plus 3 is 7 plus s upon 3 to the s plus 2 minus 4 minus 1 is 3 minus s upon 2 to the s plus 2, right? Plus, and here also 2 into 2, right? So 3 to are 6, 6 plus 3 is 9 plus s upon 4 to the s plus 2 minus 6 minus 1 is 5 minus s upon 3 to the s plus 2 and so on. So we just 1 over s minus 1. Now let's put this first, okay? So if you want negative to be positive, right, s taking minus common here, or if you plug minus 1 plus s, right, s minus 1 by 1 to the s plus 2 plus, if you share denominator 2 to the s plus 2 and 2 to the s plus 2, we can combine it, right? 1 over 2 to the s plus 2 is common, so 5 plus s minus 3 3 and 9 plus, and minus plus, so 3s, right? Plus, and again for 3, this and this will take, right? which is 1 over 3 to the s plus 2, and 3 7 are 21 plus 3s minus 6 5 are 30 minus plus 6s, right? Plus and so on. Now 1 over s minus 1, so s minus 1 over 1 to the s plus 2. 1 to the s plus 2 I can write in as 1 to the s, right? Okay. The reason is, this is just an easy one. 1 to the s plus 2 is equal to 1 to the s into 1 square, right? 1s into 1 square is just 1, so 1 to the s. Okay, that's why 1 to the s plus 2 is same as 1 to the s plus. Now 2 to the s plus 2 is nothing but 2 to the s into 2 to the 2 square, right? So 2 square is 4. 4 into 2 to the s. Now 5 minus 9 is okay, yes. 3 plus 1 is 3s plus s is 4s minus 5 minus 9 is minus 4, right? Plus 1 over same thing here, 3 to the s into 3 square, which is 9. And if you plus this to 6 plus 3 is 9s, and 21 minus 30 is minus 9, right? Plus and so on. For fourth term and so on, we have 1 over s minus 1, s minus 1 upon 1 to the s plus. Now 4 we can take common here, right? 4 over 4 into 2 to the s minus 1 plus. Here also 9 common, 9 to 3 to the s minus 1. And if you plug for 4, 16 upon 16, 4 to the s minus 1 plus and so on, right? Now we just right hand side equal to 1 over s minus 1 bracket s minus 1 upon 1 to the s plus. Now we can get cancel for 4, so s minus 1 by 2 to the s, and here also 9 s minus 1 by 3 to the s, and 16 so s minus 1 by 4 to the s. So and if you do for another time again, s minus 1 by 5 to the s, right? Plus and so on. S minus 1 taking out common here, s minus 1 by s minus 1, 1 over 1 to the s plus 1 over 2 to the s plus 1 over 3 to the s plus and so on, right? So s minus 1 cancel, so we are left with 1 to the s plus 1 2 to the s plus 3 to the s plus and so on. So this term is nothing but, sorry, this is not 6, okay, this will be s 5 to the s plus and so on, which is sum from n equal to 1 to infinity 1 over n to the s, right? Which is equal to, this term is nothing but or zeta function, zeta of s. Therefore or zeta of s is 1 over s minus 1 sum from n equal to 1 to infinity n plus 1 by 2 and 2n plus 3 plus s upon n plus 1 to the s plus 2 minus 2n minus 1 minus s upon n to the s plus 2, such that the real part must be greater than -1. So this is how I prove it, okay?